All right, in this video, we're going to go over a lot of these different equations, relationships with circles. So this page has a lot going on. That first box in the top left is hopefully something that you remember from an earlier lesson with the central angle and the inscribed angles and their relationships with their intercepted arcs. All right, now these other ones are new that we haven't used before. I hope that as we go through them, your brain will start to see the pattern here. All right. But if they don't right away, it's okay. Take your time. We have multiple days built in for mixed review on these different application questions with tangent chord angle, two chords and an angle, two secants and an angle, tangent secant angle, and two tangents angle. So again, I know it is a lot, all right, but we're going to go through kind of practice each of these slowly. All right, so on the this sheet here, if you're following along, I'm not going to do all of them because there are a lot. And I don't want this video to be like 30 minutes. So I've starred some that I think will address each of these relationships that is on that previous page, as well as kind of the different ways you'll see the questions. So check back on Canvas later after you watch the video. You can see the key for the ones that I didn't do in this video. Okay, let's start with number one. So again, the instructions here are find the measure of the arc or angle indicated. Assume that lines which appear to be tangent are tangent. All right, so this first one I'm going to do, we see that tangent here of RQ, that line that appears to be tangent, it is, and it's asking us to find this angle PQR. So if you go back up to this first one here, the tangent chord angle box in the top right, you'll see that the measure of angle 1 is equal to half the measure of that arc AB. So in this case, if I'm trying to find angle PQR, it's going to be equal to half the measure of this arc PQ, which is given to us. So the measure of angle PQR is equal to 1/2 times the measure of arc PQ. All right, so I'm going to plug in that 1/2 times 148 degrees, which would give me the measure of that angle. And half of 148 degrees is 74 degrees. So this is the first one. Okay, let's try number two. Okay, so number two, again, we're going to use that same box from the previous page, all right? But we're going to have a couple extras, or one extra step here, because what I'm going to first do is I'm going to first find this angle, since they're giving me this arc here of JK. So I'm going to find that angle, which is angle, it doesn't give me a point here, but I'll just have that angle, I'll say the opposite. Let's just make up a letter, JKLM, all right, which is going to be 1/2 times the measure of arc JK. So if I plug in what I'm given in the problem, which is 282 degrees for that arc, I can find that angle JKM by dividing 282 divided by 2, which is going to be 141. Now again, that's not what I'm asking for. The question is asking for angle LKJ, but from that first box on the top right, you'll notice it says that angles 1 and 2 are supplementary. So if I know that this angle is 141 degrees right here, I can find the measure of angle LKJ by doing 180 degrees minus 141. All right, so subtracting that is going to give me 39 degrees. So that's how we do that one. So again, that's why I starred 1 and 2, because they're using the same box from the previous page, right? The tangent chord angle relationship in our circles, but the way that we went about them was a little bit different with that extra step in number 2. Okay, let's do number 3. Okay, so number 3 is asking us to find angle KJL. So I'll highlight here, KJL, all right? Now, we're gonna be using a new box from the angle relationships notes up there, which is the two chords angle box here, all right? So you'll notice that the vertex is not it's not the center, but it is in the circle. And to find these angle measures, we're gonna take the intercepted arcs that are also the vertical angle intercepted arc, and we're going to add them together, so find that sum, but then divide by 2 to get that angle. So in this case, I am going to look at the intercepted arc KL, but then my vertical angle on the other side of this question mark is going to be UM for that intercepted arc from that vertical angle. So I can find the measure of angle KJL by adding together the measure of arcs KL and the measure of arc UM, and then dividing it by 2 or cutting it in half. Okay, so I'm going to do that by finding the sum of 105 degrees plus the sum plus 55 degrees. When you add that together, you get 160 degrees. So this angle, KJL, is going to be 80 degrees. And that is it for number 3. So that's kind of the most straightforward way you'll see the use of that one. Okay, so I'm going to skip 4, all right, because that's very similar to 3, and go to 5. All right, you'll see it's a little bit different. Now they're asking us for this intercepted arc. But we know that if we take the sum of this other arc, LM, and add arc CN and cut it in half, that would give me this measure angle. So we're going to set up that same thing. The measure of angle MKL is equal to the sum of arc LM plus arc NC, but then we're going to cut it in half. All right, now this is where you're going to plug in the stuff you know. I know the measure of angle MKL is 129 degrees. I do know the measure of arc LM, which is 186 degrees. But what I do not know is my unknown is arc NC, which I'm solving for. So I'm going to move that 1/2 over to the other side by multiplying by 2. When I multiply by 2, I'm going to get 258 equals 186 plus the measure of arc NC. So the measure of arc NC is going to be 258 minus 186. Which is 72 degrees. All right, so that is it for number 5. Again, using the same kind of process we did in 3, but a little bit different because we're not solving for an angle, we're solving for the measure of an arc. Okay, so skip 6 because that's similar to number 5. Let's jump to 7, 8, and 10. So only 3 more to go. Okay. All right, so number 7. Number 7 is using a different one from that first page. I'll go back up here. All right, it's the 2 secant angle in number 7 where the vertex is actually on the outside of the circle. So to find that angle E or angle 1 or BED, you're going to find the measure of the larger arc, that BD arc, subtract the smaller arc, and then cut it in half to find that angle measure. So let's do 7. All right, so the measure of angle KLM is equal to, let's find the measure of the larger arc, which is JQ, minus the measure of the smaller arc, KM, and then we'll cut it in half. All right, so I think they're giving us both of those arc measures. The larger arc is 140 degrees, and the smaller one is 50. So when I subtract that, I get 90 degrees. So the measure of angle KLM is half of 90 degrees, which is 45 degrees. Again, that's the most straightforward way where you're given both arcs and you're finding that angle that's outside the circle. Let's look at 8. Now, number 8 gives us that 45 degrees. Again, it's not always going to be 45, but in this case it is. All right, and we're trying to find this smaller arc. So I'm going to set up that equation. The measure of angle F is equal to 1/2 times the measure of arc VH minus the measure of arc EG. But similar to a previous question that we did, I am going to be solving for a different unknown this time. So I do know this is 45 degrees. I do know that arc VH is 157 degrees. And I'm solving for arc EG. Multiply that over by 2 to get 90 degrees equals 157 degrees minus the measure of EG. All right, when I move that 157 over subtraction, I'm going to get negative 67 degrees, but that's equal to the opposite of that arc EG. So arc EG, the measure of that, is equal to positive 67 degrees. All right. Okay, last one, number 10. Number 10, I think, is the most difficult one here. All right, this is using, on the notes, it's using this last one here, the two tangents angle. The vertex, again, is outside the circle, but you'll see very similar to the setup for the tangent secant angle is that we're going to take the larger arc, the major arc, and subtract the minor arc, and then that difference, if you cut it in half, will give you the measure of that angle. Now, the reason this is so tough and why I want to choose it is that I only have one thing. I only have this angle of 53 degrees. So what I did was I made this measure of arc JL. I just used an unknown X for that. And then this arc, the major arc, right, because there's only two arcs, this would be 360 minus X for that major arc. So when I set up my equation, let me set it up here. The measure of angle K is equal to 1/2 times the measure of the major arc, I'm going to say the major arc, minus the measure of the minor arc. Okay, so I know this is 53 degrees. This is 1/2. The major arc is 360 minus X, and then minus the minor arc is also X. All right, move the 1/2 over by multiplying by 2 to get 106. And that's going to be minus 2X. I'm going to move the 360 over a subtraction, all right, which is going to give me negative 254. So for my X, when I divide that by 2, I'm going to get my value for the X. Now, we're not going to be finished because we do have to plug it back in, but I just want to make sure that you understand how I'm getting this algebra. So divided by that negative 2 will give us 127. All right, again, that's not the answer because we do need to figure out this major arc. So I'm going to plug in that 127 where it says X. So the major arc is equal to 360 minus 127. So the major arc equals 360 minus 127, which is 233 degrees. So this is the answer, but all of the work down here was able to lead me to that answer. Okay, guys, so I'm going to pause here. All right, but again, I know I skipped a lot of questions. There's still more after this. Check out on Canvas for the key to see the answers to those other ones. All right, good luck.